Welcome, folks. Today we're diving into a fascinating study on preterm pig growth responses to different protein levels, supplemented with leucine or V-hydroxy V-methylbutyrate, also known as HMB. It's quite a mouthful, isn't it?
It certainly is. So why preterm pigs? What makes them a good model for studying preterm infants?
That's a great question. Preterm pigs are a validated translational model for preterm infants. Their development and physiology share many similarities with human infants, making them useful for studying nutritional interventions and growth patterns. This study uses them to explore ways to improve growth after preterm birth, which is a critical determinant of long-term outcomes.
I see. And what's the core problem this research is trying to address?
The main issue is that many preterm infants experience ex utero growth retardation. The goal is to match the rapid growth rate of fetuses between 22 and 40 weeks of gestation, aiming for a protein accretion of 2 to 2.5 grams per kilogram per day. However, simply increasing protein intake can overload their immature systems, leading to complications like acidosis and elevated blood urea nitrogen, or BUN.
So the researchers are looking for ways to boost growth without just piling on the protein?
Exactly. That's where leucine and HMB come in. These compounds are known to activate the mTORC1 signaling pathway, which is crucial for protein synthesis and development. The hypothesis is that supplementing with leucine or HMB can stimulate muscle protein synthesis and reduce protein degradation, even without high protein intake.
Interesting. Can you briefly describe the experimental setup?
Sure. The study involved 2 experiments. In both, preterm pigs were delivered by cesarean section at 92% of their term. For the first 48 hours, they received parenteral nutrition, or PN. Then, they were switched to enteral nutrition, or EN, with different formulas for 6 to 7 days. Experiment 1 tested low and high protein formulas with and without leucine. Experiment 2 then tested whether supplementing the high protein formula with leucine or HMB could improve growth.
And what were the main findings of experiment 1?
Surprisingly, pigs fed the low protein formula with alanine or leucine grew faster than those fed the high protein formula. Specifically, the low protein groups gained around 3.4 to 3.7% per day, while the high protein group only gained 2.8%. This was quite unexpected.
That is surprising. Why do you think the high protein formula resulted in slower growth?
Well, the researchers suggest that the high protein intake might have led to amino acids being deaminated instead of being used for protein synthesis. This could overload the system and hinder growth. Also, the MCT oil added to the low protein formulas to make them isocaloric might have provided a readily available energy source, leading to a protein-sparing effect.
I see. So what about experiment 2? Did supplementing the high protein formula with leucine or HMB make a difference?
Unfortunately, no. Supplementing the high protein formula with leucine or HMB did not significantly increase growth compared to the control group that received the high protein formula with alanine. The growth rates were pretty similar across all groups in experiment 2.
That's a bit disappointing. So what's the overall takeaway from these experiments?
The key takeaway is that leucine and HMB improved growth in preterm pigs fed low protein formulas, but not high protein formulas. This suggests that these supplements can be a viable option to improve growth without increasing the amino acid load, which can have metabolic disadvantages. It also highlights the complex relationship between protein and energy intake in preterm infants.
Interesting. The study also mentions the influence of birth weight and sex. Can you elaborate on that?
Certainly. Smaller pigs, those under 700 grams at birth, grew slower during parenteral nutrition and had a more pronounced response to leucine. This suggests that leucine might be particularly beneficial for small for gestational age, or SGA, infants. Also, female pigs fed the high protein formulas grew faster than males, especially the smaller ones. This aligns with observations of better outcomes for female preterm infants.
So, there are potential sex-based differences in how preterm infants respond to nutrition?
That's what the data suggests. The researchers noted that these findings are consistent with the lower morbidity and mortality seen in female preterm infants, particularly those who are SGA. It's an area that warrants further investigation.
What are the broader implications of this research for preterm infant nutrition?
This study underscores the need for a nuanced approach to preterm infant nutrition. Simply increasing protein intake isn't always the answer, and it can even be detrimental. Leucine and HMB show promise as potential growth-promoting supplements, especially for SGA infants, but more research is needed to understand the optimal protein and energy balance. Also, the study highlights the importance of considering individual factors like birth weight and sex when designing nutritional strategies.
It sounds like there's still a lot to learn, but this study provides valuable insights into the complex interplay of nutrition and growth in preterm infants.
Absolutely. It's a step forward in finding better ways to support the healthy development of these vulnerable infants. The study also emphasizes the preterm pig as a valuable model for future research in this area. Well, folks, that wraps up our discussion on this fascinating study. Thanks for tuning in.